In this example, we're asked to find the domain of a function h of x equals 2x plus 1 over x minus 1. Now what you should have noticed here, the fact that this function has a top and bottom, that this is a rational function. And with rational functions, they have one rule or restriction, and that is you cannot plug in any number which would make the bottom equal to 0, because if the bottom is equal to 0, then that means that the function is undefined, and you should never have a function that is undefined. So again, here the only restriction is you can plug in any number in the world into these functions. You just cannot plug in a number which would make the bottom equal to 0. So all you have to do to find the domain is simply to take the bottom and set it equal to 0, and that will tell you what number you're not allowed to plug in. So x minus 1 equals 0. To solve this for x, all we have to do here, as you can see, is simply add 1 and x equals 1. So that means I can plug in any number in the world into this function, but the one number I cannot plug in is 1. And the reason, because 1 would make it undefined. 1 would make it equal to 0. So if we remove this x and replace it with a 1, we will have 1 minus 1, which equals 0. And anytime you have 0 on the bottom, it's undefined, and we don't want the function to be undefined. So therefore, the domain, which is all values except those that would make the expression undefined, would be any number except 1. So to write that in interval notation form, basically it's from negative infinity to positive infinity, but we must put 1 there, and we put a parenthesis around 1 on both sides to indicate that it does not include 1. It includes any number from negative infinity to positive infinity, but not 1. Now we can also write this in set builder notation form, and that is x is such that it can be any number, but it cannot be 1. And there you have it.